Okay, so this is practice paper for 2014, question number 2. Again, we're asked to differentiate this function. Find the value of dy by dx when x equals 1.5. So we're going to differentiate the function and then substitute a value for x. So let's have a look at the question. First of all, if we look at our table of standard differentials, we see the differential of cos is minus sine. So the differential dy by dx is going to equal 2.1 times minus pi sine pi x, because the pi comes out. Using the standard differentials, sine becomes cos, so minus sine becomes minus cos. Again, the pi comes out, cos pi x. Tidying up. I can take a pi outside the bracket. In fact, I can take minus pi outside the bracket. And what am I left with inside the bracket? 2.1 sine pi x plus cos pi x. Now it's just a case of putting in the value when x equals 1.5. So now just substitute in the value. So when x equals 1.5, dy by dx equals minus pi 2.1 times the sine of 1.5 pi plus cosine of 1.5 pi. You might be able to think about that in terms of 1.5 pi and work out what the answers are going to be just by thinking about the curve, or we can use a calculator. If we're going to use the calculator, don't forget that you're in radians. Oops, it should have been a pi there, I just noticed. Don't forget that you're in radians when you work it out. And let's see what solution you get in when you plug it in. Here comes the solution. Well, if you've done it with a calculator or using the sketch, if we sketch it just a little bit of thought going into this, we'll look at the sine wave, and here is a sine wave sketched out. We know that's 2 pi, and so this must be pi, the halfway point, and so this must be 3 pi over 2. So this is the point I'm interested in, and what's the value of sine at that point? It's minus 1. So that's the sine of 3 pi over 2 is minus 1. Look at the cosine curve, again, that's the 2 pi point. So this is the 3 pi over 2 point here, and the cosine of 3 pi over 2 is 0. So this term has disappeared. Oops. Okay, in this question, we're asked to differentiate this function here, find the value of dy by dx, differentiate it, and then find y, or the value of the differential value, when x equals 1.5. So the first thing to do is differentiate it, and then substitute in for x the value 1.5 to calculate the differential. Don't forget, we're working in trigonometric functions here, so in the final solution at the end, make sure you're in radians on the calculator because of the pi here. So have a go. Again, pause at any point along the way. So I'm going to differentiate it. dy by dx using the table of standard differentials. Well, the 2.1 cos becomes minus sine, and the pi comes out. So that's times minus pi sine pi x. The second term, sine becomes cos, so minus sine becomes minus cos, and again the pi comes out, cos pi x. So that's our function. So we could tidy it up a bit if we wanted, and say that equals, bringing the minus pi outside the bracket, although it's not essential to do this, I'd be left with 2.1 sine by x plus cos by x. Just think about that one and satisfy yourself that you understand why that becomes a plus in here. So now all I've got to do is to substitute in the value for x. So when x equals 1.5, differential dy by dx equals minus pi times 2.1 sine 1.5 pi plus cos 1.5 pi. Then I get my calculator out, remembering to be in the radians, and work out the value of the differential. Think about the function now. If you think about the wave function, then a sine wave will look like this, where that's 2 pi, a complete term. So where's 1.5 pi or 1.5 pi? Think about that. Here's the cosine function, again finishing at 2 pi. So if that's 2 pi, here's pi. What's the value of the cos when it's 1.5 pi? So you might be able to work out what this is without actually having to use a calculator. So when you do work it out, we actually find that dy by dx equals, because when I do this, the sine of 1.5 pi becomes minus 1, and the cosine of 1.5 pi is 0, we actually end up with dy by dx equal to 2.1 pi.